Okay. Second video of chapter 3. I put the 3 problems on the board earlier. I found my calculator and I worked out the 3 problems. The first problem dealt with this thing. They gave you 15.9 grams of nitric acid, HNO3, and they want you to convert that to moles. Anytime you are given mass and you want to go to moles, you have to get the molar mass of that substance. How do we get the molar mass of the substance? You go to the periodic table, you add up the masses of all of the individual elements in that compound, and you put the unit grams there. So I did that. 1 hydrogen, 1 nitrogen, 3 oxygens, added it up, and it was 63.0 grams. So the conversion is that 1 mole of nitric acid is 63.0 grams. Why did I put it on the bottom? Because dimensional analysis, whatever unit you want to get rid of, you put down here. So I put my molar mass, set it up this way, grams of nitric acid cancel with grams of nitric acid. I plug it into the calculator, 15.9 divided by 63.0, you get 0.252 moles of nitric acid. That's the first problem. The second problem does the reverse. It gives you moles and it's asking for grams, which is exactly the same idea. You need molar mass in order to convert between moles and mass. That's should be super easy for you guys. So you put the moles that they gave you, and now you get the molar mass of the calcium carbonate. Again, you go to the periodic table, 1 calcium, 1 carbon, 3 oxygens, add them all up, you get 100 grams. So 1 mole, now notice what we did here. We put the mole down here and the grams up here. Why did we do that? Because we want to cancel moles, okay? You then do the math, 0.236 times 100, you get 23.6 grams of calcium carbonate. So if you have 0.236 moles of calcium carbonate, that is going to weigh 23.6 grams of calcium carbonate. And then the last problem dealt with using both conversion factors, molar mass and Avogadro's number. One thing to remind you of, anytime they give you particles and they want you to go to moles, you need molar mass. Anytime they give you moles and you want to go to particles, particles meaning atoms, ions, molecules, whatever, you use Avogadro's number. Well, in this problem, they didn't give you moles, they didn't give you particles, they gave you grams. So they said that the daily requirement for everybody, for an adult, male, adult, female, is 1.0 times 10 to the minus 6 grams of chromium. So each one of us needs this many grams of chromium every day. And they want to know how many atoms of chromium that is. Okay, so they gave you particles and they gave you grams and they want you to convert it to particles. They want you to convert it to atoms. You cannot go from grams to atoms. You have to first go from grams to moles. How do you go from grams to moles? Remember, anytime you want to go from mass to moles or moles to mass, you need molar mass. So you pick up your periodic table and you look up the molar mass of chromium. Molar mass of chromium is 51.986, so round it to 52.0 grams if you're going to do 3 sig figs. So I'm going to convert my grams to moles. This way I canceled out grams. I now have moles of chromium. I'm going to pick up the calculator once I've done the full setup. I can now go from moles of chromium to atoms of chromium using Avogadro's number. Remember, 1 mole of any substance is 6.02 times 10 to the 23rd of that substance. So 1 mole of chromium atoms is 6.02 times 10 to the 23rd chromium atoms. So we're going to do this conversion here. 1 mole is 6.02 times 10 to the 23rd. Our moles of chromium cancel. And now you do this divided by this times this, round it to 2 sig figs. Why 2? Because this original number here is 2 sig figs. Okay? All of this stuff over here, this I've given it all the way up to 3 sig figs. Plus, you don't want molar mass to limit you. You want just the first measured quantity or whatever they've given you at the beginning to be your limiting thing, not your conversion factor. So This is 2 sig figs. I round it to 2 sig figs. You get every day you should be consuming 1.2. Hopefully you see these decimals. 1.2 times 10 to the positive 16 atoms of chromium. Okay, so now we're done with the first couple of topics on the what you need to know list. And we're ready to move on to topic number 3, which is be able to calculate percent composition from the formula of a compound. What do we mean by percent composition? We mean basically if I give you a formula, I want you to tell me what percent of that formula is this element and what percent of that formula is another element. All right, so let's do the percent composition of, let's say, lead-2 chromate. And we want to know each element in lead-2 chromate, what percent composition that is. See, this is why I was telling you, you have to know your polyatomic ions. You have to know naming of ionic compounds, because if you don't, if I tell you what is the percent composition of lead-2 chromate, well, unless you can write the formula of lead-2 chromate, you're not going to be able to figure out the percent composition. All right, so if I just write lead Roman numeral 2 chromate, and I want the percent composition, the first thing you do is write the formula. So what is the formula of lead-2 chromate? Well, I know that lead is Pb2 plus because it's lead-2. Chromate, because I've memorized my polyatomic ions, is CrO4 2 minus. Hopefully you remember that from the last chapter and all the polyatomic ions that I asked you guys to know. All right, so they're going to hook up 1-to-1 ratio, PbCrO4. So basically what we want to do is figure out the percent lead, the percent chromium, and the percent oxygen. So we need to know what percent of lead-2 chromate is lead, what percent of lead-2 chromate is chromium, and what percent of lead-2 chromate is oxygen. How do we do that? Well, the first thing you do is you write down the mass of just the lead. So we go to the periodic table and we look up lead, and we see that it's 207.2. So I'm just going to write 207. So 207 divided by, now you have to write it down the molar mass of the whole lead-2 chromate. So, or the formula weight of the whole lead-2 chromate. So we're going to add the 207 with the chromium, which we just did as 52. And the 4 oxygens would be 64. So let's add these together. This is 13, 12, 3. Let me double check my math here. 7 and 2 is 9, plus 4, 13. 6 and 6 is 12, so 323. That would be the molar mass of the lead-2 chromate, or the formula weight of lead-2 chromate. So I'm going to write 323 down here. And then you're going to multiply by 100. All right, so you pick up your calculator and you put 207 divided by 323 times 100, and we see here that 64.1%, because it's 64.0866, I'm just going to round it to 3 sig figs. I'm going to write 64.1% of lead-2 chromate is lead. So 64.1% of the mass of lead-2 chromate is lead. All right, so now let's do the chromium. Chromium, we take the 52, which is the mass of the chromium, divided by 323 times 100. Okay, so 52, again, these decimals don't really show up very well in the video, so I apologize for that. Hopefully, if you're listening carefully, you hear me saying the decimal. So 52 divided by 323 times 100, and I don't know how to do math, so 52 divided by 323, and then you go times 100, and you get 16.1%. Let me double check. Yep, so 16.1%. Now, what you can do in this situation is, if you know what this is and you know what this is, so all you have to do is go 100 minus 64 and 16, and you'll get the percent oxygen. But for the heck of it, I'm just going to go ahead and crunch the numbers for the oxygen also. But, if you want to save some time, you don't really need to. You could just do 100 minus these guys. So 64 divided by 323 times 100. So 64 divided by 323 times 100, and you get 19.8. How convenient. It all adds up perfectly to 100%. 19.8 is the oxygen, 16.1 is the chromium, 64.1 is the lead, and that's how to do percent composition. Okay? All right. So let's do an application of that one. All right. And so here's an application of a percent composition problem. Let me put that up on the board. All right. How many grams of carbon? So how many grams of carbon are in 61.8 grams of sucrose. Sucrose is just table sugar. You've heard of glucose. Well, sucrose is just table sugar. Sucrose's formula is C12H22O11. For those of you who are moving on into a biochem class, sucrose is just a combination of glucose and fructose. And the fructose in sucrose is what makes it so sweet. We learn the structures of these things in a biochem class, but not in this class. All you need to know is that this is the formula. We have this many grams of sucrose, and we want to know the grams of carbon. How do we approach a problem like that? The first thing you can do is write percent carbon in sucrose, C12H22O11. So you do that. You go percent carbon, just like we did with the lead and the lead chromate. You write down the carbon. Now, carbon's mass is 12, and I have 12 of them, so that's 144. And I divide it by the mass of the whole thing. So I've got 16 times 11, 176, plus 22, plus 144. This is just a rough, quick one here. So that's 342. That is the molar mass or formula weight of sucrose. So I'll go 144 divided by 342. Okay, let me try that. 144 divided by 342 times 100, and that is 42.1%. So I know that 42.1% of the sucrose is carbon. Well, I have 61.8 grams of sucrose. So if I go 61.8 times 0.421, that's the percent carbon. So do the math. 61.8 times 0.421, and I get 26.0 grams of carbon. So if you're consuming 61.8 grams of sucrose, 26.0 grams of that is carbon. Okay, good. we're done with this topic.